So while I was off camera, I made up some 3 to 8, 3 parts ethyl acetate to 8 part hexane, and I've spotted 2 more sets of plates, 3 with linalool, 2-phenylethanol, and 2-phenethyl acetate, or 2 rather with each of those, and then 2 with the mixture of guaiacol, eugenol, and vanillin. And I'm going to run one of these sets of plates in the 3 to 7 solvent mixture that I prepared. So we'll put this one with the linalool, the 2-phenylethanol, and the phenethyl acetate in there, and one of these with the guaiacol, the eugenol, and the vanillin. Then I'm going to run the other set of plates in a different solvent of pure methylene chloride, because they're not separating very well in the ethyl acetate hexane mixture. So I think they might separate if I change the solvent entirely. So I'm just going to use a little vacuum to pull the rest of the ethyl acetate out of there until I can't smell it anymore. I really don't want any of the polar ethyl acetate in there. And then we're just going to use pure dichloromethane. We could also use a mixture of dichloromethane and hexane, where dichloromethane would be the more polar mixture, or the more polar component of the mixture, but significantly less polar than ethyl acetate. So we're going to run these other 2 plates in a completely different solvent system and see if maybe the guaiacol and the eugenol that are not separating well in the ethyl acetate hexane mixture will separate because of a different affinity for the dichloromethane mobile phase. So we'll let those run, and you'll notice I've taken these plates and I've marked them 1 to 9 at the top and 2 to 8. So when I take these pictures, you'll be able to distinguish between what solvent system was used and also where the compound is located. And my hot plate is now at a nice temperature. I'm going to move the ethanol a little away from that hot plate since we don't want it igniting. So we can reach some conclusions about what stain we might want to use if we're trying to pick up a particular compound. Obviously the iodine stain is quite useless on the phenethyl acetate and the 2-phenylethanol. But even though vanillin and the 2-phenylethanol have similar RFs, they have different staining capabilities, so we should still be able to distinguish them from each other by their staining. And that's also true here, right? The vanillin stained significantly more with the phosphomalicic acid stain than did the 2-phenylethanol. I'm a little surprised at how poorly that stained. Usually primary alcohol stained nicely with phosphomalicic acid. The linalool has a similar RF to guaiacol and eugenol, so those 3 compounds might be really difficult to distinguish in the 1 to 9 mixture. In the 2 to 8 mixture, it does appear that now this one has a RF that's different enough that we would be able to distinguish them. Unfortunately, there's a little impurity in the linalool that shows up right about the same place as the other 2. That's unfortunate. And they all stain similarly, although linalool less dark than the other 2. But it would be really nice if we could have a solvent mixture that had a little bit different, a little bit of a bigger RF difference for those 3 compounds. I'm confident that with this 2 to 8 solvent mixture, we can tell the difference between the vanillin, the 2-phenylethanol, the 2-phenylethyl acetate, and then the other 3. But maybe telling those 3 apart isn't going to be as easy. Linalool and 2-phenylethyl acetate have reasonably similar RFs, but way different staining properties. And in the 1 to 9, right, significantly different RFs. So if we're thinking we might have a combination of linalool and 2-phenethyl acetate, the 1 to 9 solvent mixture would actually work fairly well for distinguishing those. It's trial and error, really, to figure out what your solvent mixture, what the optimum solvent mixture is going to be. That's not close enough to the top yet. It's not quite done. So sometimes a literature reference will tell you the appropriate solvent and give you an RF value, but often it'll just say TLC and ethyl acetate hexane and not even tell you the ratio, which is less helpful. This is no longer 2 to 8, so it's also a very dirty beaker. which is why my solvent was coming out cloudy. It'll be clean by the end of the day. Trash can. So I will be running 21 different unknowns and uploading pictures of the TLC plates with those unknown numbers marked on them, and then each of you will be assigned one of the unknowns to analyze and try to figure out what you think is in the unknown, and you will tell me which co-spot tests you want me to do, which things you want me to test it against, at which point I'll do that for you and upload the results so that you can conclude whether or not so you can decide whether or not you reach the right conclusion. So those are our 3 to 8 mixture, or 3 to 7, sorry. So I'm going to label them as such. Let them dry. And maybe the dichloromethane plates are done. Yep, close enough. It's not really critical exactly where that line comes to. It's just critical that you know where that line came to so you can mark the solvent front. The closer to the top of the plate you let it go, the better from the perspective of using the entire separation capability of the plate. Once you have stained something, the UV light is no longer usable because the fluorescence will be quenched by the stain. So it's important that you look at them under UV light and mark the location of the spots before you do any staining. So we've got our 2-phenylethanol moving quite nicely now. And our 2-phenylethyl acetate, actually I have these labeled backwards. This should be the phenylethanol, this is the phenethyl acetate. So this is a really nice separation for those two. We don't know where the linalool is. It looks like there's something up here, which may or may not be the linalool. The vanillin is now moving nicely. It's a good mixture for that. And there's the eugenol. You can see that the eugenol and the guaiacol are still stubbornly moving about the same distance in the 3 to 7. So there's not much to distinguish them. That extra hydrocarbon chain isn't really helping. So in the pure dichloromethane, I think you can see that the RF values in the pure dichloromethane are somewhat similar. There's a slightly bigger separation in the pure dichloromethane between the phenethyl alcohol and the phenethyl acetate than there was in the 3 to 7 mixture. We'll mark that as CH2Cl2 so we know that was the dichloromethane plate. And there's our vanillin. So even in the dichloromethane, our eugenol and our guaiacol are proving not to separate very well. Again, we've got a slightly bigger separation here in the dichloromethane than we did in the ethyl acetate hexane mixture. Usually when you're running TLC, you'd like your spots to be somewhere between an RF of about 0.3 and 0.7. That's kind of the optimum center of the plate for separation. So in the 3 to 7 mixture, we're not quite sure where the linalool will be, but it's certainly a good mixture for the other components. And so is the pure dichloromethane. We've got our spots kind of in the range where we want them. Our guaiacol and eugenol are more different from the phenethyl acetate here than they are in this plate. I don't know if you noticed that when I did this, there's a spot up here as well, because I accidentally put the 2-phenethyl acetate on the 2-phenethyl alcohol spot, and then realized I was putting it in the wrong place and put it down here because I had them labeled backwards. PE is phenylethanol, PA is phenethyl acetate. So now we're going to see where the linalool is by staining this plate in the iodine chamber. And we might as well stain the other one in the iodine chamber as well. Now we're at it. Just shake those around so that the plates are fully submerged. And we can let that sit. That's a 3 to 7 mixture. And I'm going to stain these two, the dichloromethane plates, using the phosphomolydic acid. Nice hot plate. Let it drain so we don't waste our solution. And let those plates dry. I'm going to go ahead and put this back, and I will show you the stock bottle from which this was filled. So what we're looking at here is a phosphomolydic acid 20 weight percent solution. I think I said 12, I meant 20. Phosphomolydic acid 20 weight percent solution in ethanol. Right, so that's basically 20 grams of phosphomolydic acid per 100 grams of solution in ethanol. It's got a density of 0.94. And the formula for phosphomolydic acid is H3MO12O40P. So it's a quite complicated thing, 1,825 molecular weight. And that's from Acros Organics. So we know from before that the linalool is going to stain, and I can kind of judge whether I've got that on the plate for long enough by watching the blue color of the linalool up here. I'm holding a little bit further away from the plate this time because I know that the hot plate is actually hotter than it was before. It's been heating for a while. So I'm also going to flip that upside down, back and forth a little bit to try to make sure it doesn't curl. Resting it on the hot plate like that just allows me to, not shake as much. So I keep it at a more constant distance and don't risk dropping it on the plate. So you can see the linalool is going blue. You can see it nicely through the back of the plate. Plate's definitely curling a little bit. And I'm just going to let that go a little longer because I want the orangey color to show up for the other two. Still got that impurity down towards the baseline. There's something very polar as a contaminant in the linalool. We've got some orange. These are gradually staining a little bit I'm going to push the envelope a little bit here and leave that sitting maybe a little longer than it should, just to see if I can get that phenethyl alcohol to stain a little better. There. So you see, if we let it develop a little longer, we do get a little bit better staining for the other two compounds. So sometimes it's a little bit tricky knowing exactly how long to leave it. You can see that there's a big difference. We've got two impurity spots in our linalool, and in the 2,8-ethyl acetate hexane, that middle spot moved closer to the linalool itself, but in the dichloromethane it's closer to the baseline. So sometimes the solvent mixture that you run it in can make a significant difference. Eugenol is staining blue first. That's that pi bond. And then we know that the vanillin is going to go orange. The guaiacol definitely stains more slowly and not as dark as the eugenol with the phospholiptic acid stain. So even though they have very similar RFs, staining might be able to tell the difference. The vanillin, that aldehyde, is staining orange, but it's not staining very dark. Definitely iodine is a better stain for that one. So we'll turn that off and let that cool. Turn this all the way back down to 0 before I put that away. Unlike the other plate, I'm not going to put that away while it's still hot.